Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder how your brain manages to focus on one conversation in a super noisy room, like a busy party? Well, this new study dives deep into that very question. It is something we all experience, right? You are at a party, tons of people are chatting, music is playing, but you can somehow zero in on your friend's voice. Scientists call this the cocktail party effect, and for years they've been trying to figure out the brain's secret sauce for this amazing ability. One idea that has gained a lot of traction is that our brains might be naturally tuning into the rhythm of speech. Think about it. Speech isn't just random sounds. It has a flow, a rhythm, especially in how the volume of the voice changes over time. This is called the speech envelope. Researchers, including the ones behind this study, have been testing a theory called the selective entrainment hypothesis. It basically suggests that by locking onto the rhythm of a speaker, our brain can better predict what they're going to say, making it easier to follow them, especially when other voices are competing. Now, some earlier work by a team led by Macaulay really got this ball rolling. They did experiments where they messed with the rhythm of either the target speaker someone was supposed to listen to or a background speaker. And here is what they found, which was pretty wild. If they made the target speaker's rhythm weird, people did worse at understanding them. But if they made the background speaker's rhythm weird, people actually did better at understanding the target speaker. It's like distorting the background noise made it easier to ignore. The researchers behind today's study wanted to see if these findings held up with more natural-sounding speech, not the kind of very structured sentences used in older experiments. They also wanted to look directly at brain activity to see if they could measure this tuning in effect. So they set out to do two main things. First, to repeat those fascinating behavioral results with more realistic audio. And second, to use electroencephalography, or EEG, to see how the brain's electrical signals responded to the speech rhythms. For their experiment, they recruited 20 people. These participants listened to snippets of speech where one person was the target speaker and another was the background speaker, talking at the same time. They were told to pay close attention to the target speaker and answer questions about what they said. They tested 3 different scenarios. In one, called Target Rhythm Distorted, or TRD. They scrambled the rhythm of the speaker they were supposed to be listening to. In another, Background Rhythm Distorted, or BRD, they scrambled the rhythm of the other speaker, the one they were supposed to ignore. And in the third, no rhythm distortion, or NRD. Everything sounded natural. And guess what? They found the same pattern as the earlier studies. When the target speaker's rhythm was messed up, people's accuracy in answering questions dropped significantly. But when the background speaker's rhythm was messed up, their accuracy actually went up. This strongly suggests that the natural rhythm of speech plays a big role in how well we can pick out one voice from a crowd. But they didn't stop at just listening. They also hooked everyone up to an EEG machine. EEG measures the brain's electrical activity and can show how well the brain's electrical rhythms are syncing up with the rhythm of the speech they're hearing. They used a specific measurement called phase locking value, or PLV, to see if the brain was in training or getting in sync with the speech envelope. And they found something really cool here too. Across all the conditions, the brain showed a stronger sync, a higher PLV, to the target speaker's speech envelope compared to the background speaker. This is exactly what you'd expect if the brain is actively focusing on the target. It's like the brain's internal drummer is keeping time with the speaker you are paying attention to. What's even more exciting is that this difference in brain syncing between the target and background speakers changed depending on the rhythm condition. This means that the way the brain tracks a speaker's rhythm is directly influenced by whether that rhythm is distorted in the target or the background. This is a more direct neural glimpse into why the behavioral results happened the way they did. It's the first time this has been shown with more naturalistic stimuli. So, what does this all mean? Well, it really strengthens the idea that speech rhythm isn't just a nice-to-have feature of how we speak, but a fundamental tool our brains use for selective listening. Think about it. Natural speech has these subtle, perceptible regularities. When those regularities are intact in the speaker we want to listen to, our brain can lock onto them more easily. This allows for better prediction, better attention, and ultimately, better understanding. And when the rhythm of the other speakers is messed up, they become less sticky to our brain's attention. They become weaker competitors, almost like static on the radio fading into the background, leaving the clear signal of our target speaker to shine through. This could explain why distorting the background rhythm actually helped people focus on the target. This connects really well to theories like dynamic attending theory, which suggests our brains have internal timing mechanisms that actively synchronize with external rhythmic patterns. When speech has a rhythm, our brain's internal clock can align with it. boosting attention to those moments when information is most salient. Now, like any good science, this study also opens up new questions. For example, they noticed that sometimes the overall brain syncing to speech was a bit lower when any rhythm distortion was present, regardless of whether it was in the target or background. This suggests there might be a general effect of rhythm disruption on neural processing. That needs more exploration. They also found that the specific brain areas showing these rhythm-influenced differences in attention were in unexpected places, like certain frontal channels, not always the traditional auditory processing areas. This means we might not fully understand all the brain regions involved in processing speech rhythm for selective listening, especially with EEG, which has limitations in pinpointing exact locations. Future studies using other technologies could help map this out better. And one more point worth mentioning, the study mentioned that their participants might have been a bit too good at the task, especially since many had musical training. This might have made it harder to see a direct link between the brain's rhythm tracking and their performance. It's like trying to find a correlation between speed and a race car driver's lap times when everyone is already going as fast as possible. A wider range of abilities, perhaps in older adults, for example, might show clearer links. This leads to a really interesting future direction. Understanding how rhythm processing affects speech perception, especially in populations that struggle more with noisy environments like older adults, could be incredibly useful. It might reveal unique ways rhythm helps or hinders them. And who knows, by understanding these rhythmic mechanisms better, we might even develop new ways to help people with hearing difficulties, perhaps through rhythm-based training or interventions. Imagine using rhythm to retrain the brain to better tune into speech. That would be amazing. So, to sum it all up, this study gives us more strong evidence that speech rhythm is a crucial silent partner in our ability to hear and understand each other, especially in noisy environments. Our brains are constantly listening to the beat, and when that beat is clear, we're better able to focus. What do you think about this? Does it make sense that rhythm plays such a big role? Let me know your thoughts in the comments below. And if you enjoyed this dive into the science of hearing, please give this video a thumbs up, subscribe to RUBIN'S Mind Lab for more fascinating research breakdowns, and hit that notification bell so you don't miss our next exploration into the amazing world of psychology. Thanks for watching, and I'll see you in the next one.